answered. So yes, you can have until tonight if you like totally haven't worked on it. But pause. Have we done some of this already? The answer is yes. And we worked on the basics of the math this morning, right? About our forever card. Is this good? Yes. What is better? This one. Where you think of quantity and you think of rate. Where you think of quantity and you think of rate. Calm it down, calm it down, calm it down. Okay. Okay, here we go. We want to make that a good day for you, so let's do this right now. We already started number 1, and if you weren't here for any reason, we have some work on the Jamboard. Question, did we actually solve all of these? No. But what were we going to do for 1A? If they give us a quantity equation, how do we find the rate equation? Take a derivative, quick power rules, right? Boom, 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 boom. For part B, if they want the rate at a time, all we got to do is plug in. Guys, is there any integration yet? No. What are the proper units going to be for the rate in this situation? What are the proper units in this situation? We didn't write it down. I can write it down now. Yeah, right? Check it, and then go find what they put. Perfect. And it is a rate, so it's meters per second. That was EMO, right? Good. How about part C, the average rate of change? Oh, that's not calculus. Oh, no. Average rate of change, that's old school. That's like slope between 2 points. Just cut it. Don't care about the curvature. Just go straight between 2 points and say, what's the change in position over change in time? What's the meters, the change in meters that happened over the change in time? This is precise. At one time, what does the speedometer say, kind of? This is like, you know, I've been traveling for 12 hours. 12 seconds. How far have I gone? This is the average. Okay, there's one, there's the other, instantaneous or just the rate and average rate. Both solving for the same thing, both solving for meters per second. P.S. One quick way to visualize this. We have delta S over delta T, and this is ds over dt. There is no other way to solve this. I need some sort of change in S over change in T. Either an old-fashioned, like someone not in calc could do it, like last year, or, no, you need to know your calculus to be able to do that. Part D. Wait, did we even have to do? Why am I setting equal to average? Find the average rate of change. Indicate. This is not necessary for this problem. This is MVT. I don't see MVT happening. It didn't when... Well, I'm checking though. Did it ask when the average equals the... I don't see it. It just says find the average rate of change. Yeah, it just says find the average rate of change. Okay. I think I was trying to be like, hey, there's no integral yet. This is where an integral could show up. You have to go back to that video and see what I was doing that day. Okay. And then not moving. What do we know about not moving?
It's 0.
At rest, and what's 0 when it's at rest? Velocity. Because I could have moved somewhere and then stopped. And I'm not at the initial position. I'm somewhere else, but I'm stopped. And the only way you know that is the velocity equals 0. Velocity is the same thing as, there weren't even any integrals on number 1. So then, I think I have all the questions. It's like, well, let's go look for integrals. Number 2. This is like a typical motion just to get us started, things that we're used to. All right, number 2. Isaac.
For the first line, we're supposed to like plug in the numbers, right? Like that's just the general idea.
Yeah, this is making sure you guys have the general idea. Today we're troubleshooting the general ideas. Today we're troubleshooting the general ideas. So you guys are going to submit your best hypotheses of the answers by 11:59 tonight. And then we're going to go ahead and grade it just real quick as an intro next time. Is that cool? And then go over questions of those you missed. Number 2, the number of gallons of water in a tank. T minutes. Do you guys see how we moved away from motion?
Yes.
Now, is there movement? Yes, but it's not like meters. It's water that's coming out. We got to read those words and know what they mean, right? The water's coming out because it's draining. Is that cool? Movement? Yes. Calculus? Probably. Motion, well, not in the traditional sense of what we call motion in like physics. What's going on in part A when it says how fast is the water running out at the end of 10 minutes? What do you think? How fast? Take it one thing at a time. How fast? Benny, what do you think?
Is that position?
What would be position in this scenario? Position, remember, go back to the very beginning. Position. I guess I didn't really write it, did I? I was kind of like alluding to motion over here. Position is kind of like quantity. Does that make sense? Like where you are is kind of like what you have, because where you are is like how far is a distance, and quantity is a linear measure like gallons or like feet or like, I don't even know what else. Bananas, that was one. Customers, that was another one. People in the amusement park, that was another one. Tickets that have been turned into name a baby elephant, that was another one. I'm literally like quoting off FRQs from past AP exams. But number, does that make sense? A number. So quantity is like position, so careful. I don't think how fast.
Oh, it's accelerated.
Okay, so we need something that moves. How fast isn't going to be the gallons. I'm not plugging into Q because that would be how much. Does that make sense? So this would be my how much. Is that cool? How far, how much, similar idea. Quantity. How many, similar. But how fast? You guys help him out. He's the only one participating. Where are you? Acceleration, what do you think? How fast?
Yeah.
Acceleration is how much faster, right? Acceleration is you're going faster. That's talking about the rate changing. Wait, does that make sense? Acceleration makes you go faster. That's a comparison of rate. How fast, that's just looking at your speedometer, right? Has nothing to do with this. You could be on cruise control and you're still going how fast. Does that make sense? So acceleration could be 0 and I could still be having a how fast. So I'm not going to acceleration. What did we forget in the middle? If we're thinking motion, velocity, but question, for this scenario, I'm not going to say velocity. What? I'm not going to say velocity. I'm going to say rate. And how do we find rate? How do we find rate?
The integral of...
Careful. It's all good. It's all good. It's all good. It's all good. No. It's all good. This isn't the AP right now. It's okay. Take a breath. We're good. We're good. Come back here. This was all about how fast. There are two different ways to do how fast. I want a per, right? Miles per hour. Feet per second squared. I want a per. That's acceleration. But either way. I want a per. I can either do it with a derivative and do it at one time, or I can do a per over a time interval and have an average. What do you think this is asking if it's saying how fast at the end of 10 minutes? Is that an over or is that an at? Do you see the difference? Once again, here's an over. Here's an at. When Sarah said at, that should lead us to, we're trying to find Q prime of 10. Does that make sense? Are we trying to figure out the rate at the end of those 10 minutes? So at 10. Is that cool?
Yes.
So I'm using a derivative. I'm not using the over. I'm not using the average. I'm using the derivative. Hey, cool kids. Didn't I have you have your calculator out earlier? Can you take a derivative on your calculator too? Wait, do you remember that's a thing? But instead of using alpha window number 4, Sarah, I'm coming to you right after I show them this. Instead of doing alpha window number 4, I do number 3. And I can do a ddx. You can make it some other letter, but guys, isn't x the easiest button for a variable to hit? Right? And then I would need to plug in my 200 times 3 minus t. Just make it an x, no big dealio, squared. Okay, is this going to work? Yes. But this is in the midst of a big old word problem that could have an A, B, C, D. Is there somewhere else I could have typed in this equation and then used it over and over and over again? Where's that other place I could have put it? I'm not saying you have to. I'm just reminding you you could. You could have thrown this guy in here, right? You could have put on a squared. And then what could I have done instead? I'm going to hit enter. It's going to work. 2,800. That's a lot of gallons. Wait, no, that's a speed. We'll get back to the units in just 1 second. Maybe some of you can already know what it is by looking at what's up here, using what Mo did a second ago. But coming back, couldn't we also have done alpha window number 3? And done ddx of, what did I just put into my y1? Yeah. Do you remember how to get the y1?
Yeah.
Alpha? Just start hitting the buttons, but yeah, it's alpha F4. Hit the enter and say, uh-oh. Well, that didn't work. Alpha, window. I don't think I did ddx. Alpha, trace, number 1. Boop. And I can use it over and over again. It's just a cool little trick. Remember today when you felt pressure, the time pressure on some of those problems that you were doing, right? I just gave you a little bit of a, okay, I need to get better at going fast in my calculator. Not that on the AP, every question is timed, but it kind of is. You don't want to spend more than 1.2 minutes if you can avoid it on the multiple choice section. Anyway, coming back. Either way, it's going to be 2,800, but the question is, once again, you guys need to help me out. What are my units? Got it. And doesn't that also make sense with what the notation would be for the derivative, right? It's not dy dx, it's dq dt, and the q is measured in gallons, and the t is measured in minutes. These are all things to make the connections to where your brain can understand and remember. But that's just part A. Oh, I gave you an answer. Oh my goodness. Isaac, all right, I guess I'm helping on some. But part B, what are we going to do? It's going to be a squiggly. Well, I mean, I guess I can say equals, but only because they say find the average rate, right? So I'm not approximating an instantaneous, or else I would put the squiggle. They just say find the average, and I say, okay, I'm going to say the average is equal to, but how am I going to find it, and why am I doing green?
Green is for
Algebra.
Green is for going back. Green is for review. Green is for we don't need calculus. Green is for, oh, hey, remember? Physics people, F of B minus F of A over B minus A, average rate. Calculus people, F of B minus F of A over B minus A, average rate from first semester. Oh my goodness. Pre-cal chapter 1 average rate? Snap. The question, aren't I going to also get a change in Q over a change in T? It means, well, the units will be the same, just this one I'm deriving to get it. This one I'm like, well, I don't know, well, I'm not using derivatives. But wait a minute, what's my A, what's my B? Oh, easy, they give it to me. There's the 10, there's the 0. Hey, why did I have you throw that guy into your Y1 just a second ago? Because on the AP, they don't want you doing any plugging and chugging right here. It's a calculator FRQ. They want you doing it all right here and giving them a nice little answer and saying, psh, we're not going to give you points for doing it the long way. Just do it. What? Benny asked me a little bit ago. Benny, remind me, where's that cool fraction button? Do you remember? Do you remember the fraction button?
Oh, alpha F1.
Yeah, good. Alpha F1 or alpha Y equals. The rest of you guys have been practicing that for a little bit. I was just letting him refresh. We got it all. But how do I plug into Q? All of us can, as long as you've done what? Put it in your Y1. Does that make sense? If you put it in your Y1, then we can go ahead and get up there and say F4, alpha trace. Yeah, Sarah was saying it. And can't I just say plug in the 10? They don't want to give you points for this because they're like, you should just be doing this on your calculator if it's a calculator question. Plug and chug. But show them what you're doing. This gets points. But not the extra math that you would waste time doing. Just throw it all in and say, woohoo, there we go, 800. So wait, if the rate at 10 is 2,800, and if the average rate is 800, what does it sure seem like it was doing over those 10 minutes? It's not asking you this question, and I don't I'm just trying to give you some context to what's going on. If the average, come on, my practical thinkers. I know you're out there. If the average over the 10 minutes is 800, but at 10, it's 2,800 gallons per minute. It's draining faster and faster and faster and faster, right? And probably in some sort of exponential way where it's like, oh, whatever, it's going. Oh no, right? Maybe if you can catch the leak fast enough, it won't be that big a deal, but if you don't, it might get unmanageable. Anyway, that's just like a practical thing. They're not asking, we're gonna move on. Oh, I gave you 2 answers. Hey, number 3, didn't we do some of this work the other day and I gave you most of the answers? I didn't give it to you, we did it together, but why did I, before the test, make sure we do number 3? Because there was a problem on the test that was wasn't even as deep as number 3, but this did get us into the integration is net change idea. I think on the test, didn't you guys just have to do something like this? I think it was something like that.
Oh, let's go.
And it was like a f of b minus f of a sort of thing. I think it was an f of b minus f of a sort of thing. But anyway. Question. What is different in this problem regarding rate? What is different?
Vic.
Come on. What is different in this problem regarding rate?
Can you repeat your question?
What is different in number 3 than number 1? Someone might want to help him on out, unless he has the whole thing done. He's literally like on top of the world, but just double check. Double check. But question, what is different in number 3's rate than number 2 and number 1? Let's look it up.
There is a trig.
I mean, yeah, but think bigger picture.
We're given rate.
There's a square root, there's a sign. We're what?
Given rate.
How is that different than these ones?
Oh my god.
What were you given?
Function. Oh my bad.
Did you say it? What were you given in here?
Just an equation.
Amount. Does that make sense? I mean, careful. That's an equation. Right? But that's an amount we're solving for rate either with calculus or like average or instantaneous. This one, what have they given us? Do you see it? Do you see it? If you're seeing the units first, that's perfect. You're making the connection. You can still figure out, oh, gallons versus gallons per minute. Different, right? This is the rate. So when they say find the rate at 4, am I doing any deriving? No, I'm just plugging in. They gave me the rate. Plug and chug, and you have your gallons per minute just by what you already had. P.S., just in case somebody's borrowing your calculator, all of our mode for radians, aka trigonometry, happy Pi Day, happy Cassie's birthday yesterday. Ugh, kept on thinking it was today. Question. Lost what the question was. Oh, what mode should your calculator be in for trig? Always?
No.
Stop, yes, for all of calculus.
Oh.
For pre-cal.
Why are you looking at me like that?
Vic.
What the heck?
It's like I was following you, come on.
Blame it on me?
I thought so too.
Coming back. In pre-cal, did we go between radian and degree? Yes. In physics, could you maybe be using degrees sometimes?
Oh yeah.
Yes.
I
In
don't know.
calculus, I'll remind you before your mock AP. I'll try to remind you the morning of the actual AP.
Right now we're in radians.
Always in radians. In calculus. Here we go. So was this just a plug-in chug?
Absolutely.
Did I show work?
No.
Because that would just be a waste of time. I throw it in, I hit enter, I write it down. They're not going to give me tons of points for this. They're going to give me like, cool, maybe 1.5, maybe 1, and then there's like a units point somewhere. Show them what you got. Letter B. What's W talking about? Quantity. How much? How do I go from rate to quantity? How do I go from rate? That wasn't helpful. To quantity.
Integral.
Pause. Somebody a little bit ago said something about. Somebody a little bit ago said something about. Somebody a little bit ago said something about. I want rate, let's integrate. And I said, no.
Okay.
That's a derivative. Andy, ready? 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 Ready?
Oh, yeah.
When do we
Got this, Andy.
need an integral? When we have rate and we're going where?
Amount of water.
We're going back.
Oh.
Right? Derivatives move us forward. Integrals move us backward in the progression of amount, rate of amount, and the rate of the amount. And the progression of the how much, the how fast, and the faster, slower. Coming back. Write a function of W that can be used to determine the amount of the water. Question. Over or at for letter B? Over or at?
Oh.
Keep reading, keep reading.
Wait for
At. Is it at 'cause it says that?
Nice.
Right, we're so good, bro.
It's okay. Pay attention to detail. Usually our strong student. Can be dangerous. At instead of over.
But it's at any comment.
Exactly, at.
Oh shoot.
Pause. Do you see how that makes a big difference?
Yes.
For over. No. Hold on. That's why I'm here. For over. This would be the change in amount that occurs, ready? Over the time interval. The integral that goes backwards from rate will find for me the displacement. Come on, physics, the displacement, aka the change in over. But if I want to know where it's at, I have to start with what I know. What do I know? I know an amount because they gave it to me. True. You see it? Start with what we know, add the change that occurs. And then we know where we're at. Do you see it? The at is this part of the integration is net change. The over is over here. P.S. I just erased it on the board and I really wish I hadn't. But wasn't this the one that a lot of you guys thought was easy in our practice problems? Weren't you finding an amount at starting with what you knew, adding the change that occurred? Do you see it? It's the exact same math.
But anything minus or because the water's coming out of it.
We'd have to figure out what's going on as far as the actual integral itself. In a sense that, I haven't plugged it in yet. Let's check it. If we were to go ahead and do, did I solve this one? I don't think I did. Alpha window number 4. And we're doing it, does it say how long? It better. We can check it on letter C, because letter C says from 0 to 6. Oh, we already solved that one. Struggle bus. I'm glad Hovan woke up. Because check it in letter C. We hadn't gotten there yet. So I actually would have caught it, but not until letter C. Hold on to that for a second and then be ready to pop off with everybody if they haven't already heard you. Hey guys, in letter C, what's it asking for me to do then? Once I've set up my integration as net change formula. Figure out how many gallons of water are in the tank. Wait, Mo, what's that key word we gotta see? Sarah's got you. The amount in the tank at, so can't I use the formula for at from letter C? And that's exactly what we did. But we had to start with what we knew, which was occurring at what time? 0. If it was at 3, if it was at 10, if it was at 15, I don't care. I would have that be my bottom bound, like the one from the quizzes at the beginning of class. But start with what you know. His time was 0. The change in time was from 0 to 6 of my RFT. Hovan, why does that answer not make sense? And why should that, if we just keep our wits about us, know that we did something wrong and make a change to make it right? What's wrong with 126.668?
Bigger than
It's bigger. And what did you just say a little bit ago is happening in this problem?
the water's coming out.
The water's going out. So question. Did anybody miss something on their chapter 4A test having to do with dropping, and you put a negative number, and I said, nah, the dropping was the negative?
That sucked.
I know,
Oh, yeah.
but check it.
This is D&D.
Check it. Wait.
What?
In the last test, there was the motion word problem. The motion word problem on the last page. The motion word problem on the last page said, how fast is it dropping? You should have given me the absolute value, the magnitude, because the word dropping meant negative. If you said dropping and a negative, that's a double negative. If you ain't doing nothing, you're doing something. You just ruined. You ruined the problem. Coming back. This isn't English, but it kind of is. What do they say? Flowing.
Out.
They've given me the speed. They've given me the absolute value. So when I just said, yay, add the rate, don't worry, if it's negative, it'll all work out. Did it work out?
No.
Because where was the subtraction? In the words, not in the math. What did I need to do when actually solving? Oban, what do we need to change? It was in the words, it wasn't in the math. The R did not, that rate did not have the subtraction, but wouldn't we have seen that if we solved it? It's not going up. Take a step back for a second and be like, does this make sense? Okay, sure, it's less than. No, it's bigger than. So stop, go back. You know water's draining out. They told you water is draining out because it says flows out of. This isn't calculus, this is just, oh, flows out. Okay, subtract. And if I was to subtract it instead, well, you'll have your right answer. Go adjust. Sarah.
So for B, it also be subtracted?
Because we just followed the f of b equals f of a plus a to b of the rate, which is great if the rate had the subtraction in it, but they used the words that should have led me to do the minus. But isn't it cool that you could always just like put in some sort of, okay, if I go from 0 to anything, even if they didn't ask me letter C, you could always plug in one and say, is it going down? If it's going down, we're good. If it's going up, we're not good. Thanks so much. Good catch. And also the reason why you guys have to go find the new answer to number 3. How about number 4? Who's been there? I know some of you guys are working on this worksheet. P.S. We are not starting slope fields today, obviously, so our whole calendar is going to change. Instead, we'll do slope fields on Thursday and Friday. Minimum day. We're just going to keep on going with integration as net change. Can I just give some hints to finish us off, and then we'll grade this next time? Sound good? Where are we at? Hey, guys. So find your bearings. Ooh, physics. Oh, pre-cal. We did it. Question. What'd they give you? This is why I wanted you to have the piece of paper. I want you highlighting. I want you underlining. I want you picking out the most important pieces of this problem. Guys, what did they give you in number 4? Rates, right? It's crucial that you know that. To be honest, they could throw any random situation at you. People getting on or off an escalator. Stuff coming in or out of a funnel. Bananas being put or not put on a stand in a supermarket. A pot of tea that's cooling down. I don't know. And those were all real problems. Those were all real problems! Janet shoveling snow in the driveway. Karen riding her bicycle to school. All of this stuff. It doesn't matter. You just need to know rate. So question. What are my units? Evil? What are you talking about? What are my units? Woo! There it is. If you didn't catch it there, you should catch it there. It has a per. Right? If they say for letter A, you guys are not letting me help you. Time is almost done. Write a function W of t to solve for what?
amount of water.
I want gallons. How do I go from gallons per minute to gallons?
Integrate.
I integrate. But if I am integrating, aren't I doing a change? What do I need to also see? Mo, find your word.
Nice.
So if it's an at, I want this guy, which means I need to start with what I what?
No.
What do I know?
The rate.
You don't.
Then don't tell me anything.
Single start.
We just skip this one.
Wait, can you go to B?
It's not very AP.
Yeah, are you able to do that? Like,
Can we go back to it?
are you able to go to B and that they give you 10?
Why is this one like this instead?
Oh my goodness.
I don't know.
No, it had at! This isn't over! I don't understand!
I got that.
What's the context?
Thanks, Vic.
What's the context?
You said, don't worry, guys. I got this. I got that.
It was one little mistake. It doesn't want how much water is on the field. What does it want? Why does that make a difference?
Because it's we were given the rate at which it was.
How much water was dumped is the change in what happened as it was sprayed. Does this now bring in like a, oh stink, we can't just memorize one little word and go with it? But what did you also notice? Thankfully, what were you not given? How much water was sprayed? You can think of it this way. How much water was sprayed at the beginning when they were turning on the sprayer? So, do you technically have to change what we did? Or could you just say, well, how much was sprayed when it was first turned on? None! It was just turned on! You see it? You could also do it that way. That works. That works. It was just turned on, but you gotta kind of keep your wits about you, right? So then letter B, do I really have to? Well, not really, because in letter B, I just have to say what happened in the first 10 minutes. Well, in the first 10 minutes, from not spraying anything to spraying, let's solve, right? How about number 5? What's happening now? What'd they give me?
Rates.
Rates. What am I modeling this time?
How much sand?
Sand being removed, but this is the how fast. What's going on when it says how much will have been removed after 6 hours? Is this how much sand is on the beach or how the sand has changed? So that's going to be an over. Does that make sense?
Yes.
And so all I really need is just a 0 to 6 of my R of TDT. How about number? What do we need to see? If I were you, I would see something like this. Is that adding or subtracting? Adding, it's entering. But then what else is happening?
Subtract.
Woo-hoo-hoo! So now all of a sudden I have an E of T. I'm just trying to hint. If you guys want to take off, you can. But I also have a removal rate. And a removal rate is going to be 645. Ovan, should I probably put a subtraction in here somewhere? Yes, you should. Bye, guys. See you later. I love you. Well, we'll grade it first thing on Thursday. Sound good? So I'm going to go ahead and change that deadline to Thursday, 8 a.m. to have your, well, yeah. Thursday, 8 a.m. to have your best guesses, and then we'll grade it in class.
Are we gonna turn it in person?
Yeah, you'll turn it in person. And just mark it as done online.